Welcome to RobotGeek 101. Today we're going to take a look at the RobotGeek Arduino and use its digital output pins to control devices like LEDs and buzzers. This guide is focused on the Geek Arduino but will work for any Arduino-based board using the Arduino IDE. This guide is going to assume that you've already gone through the Geek Arduino Getting Started guide that'll help you install the IDE, all the drivers, and get everything tested, make sure it's working before you proceed. So if you haven't gone through that, make sure to go through that guide first. As a quick check, here we've got our USB plugged into our computer, into this micro USB on the Geek Arduino board. And we should have a green power LED over here. We've also got our two switches. Both switches are inwards towards the board, so the reset RST is set to auto, VCC is set to 5V. So let's take a look at the Arduino IDE. You may have already programmed this with some program before during the testing phase. We're going to flash it with a fresh firmware so that we all start at the same point. So we're going to go File New. We're going to get another copy of this bare minimum code. So this is the bare minimum you need to successfully upload to the Geek Arduino, but it's literally going to tell the Geek Arduino to do nothing. Before we can upload, we just want to verify that board is on Arduino 2009 10.000. Processor at Mega 328. These are specific to the Geek Arduino board. Then you're going to have this port. This port is specific to your Geek Arduino board. So on my Mac, it looks like this USB serial with this number. On your PC, it's going to be COM1234. If you're unsure, just go ahead and unplug the Geek Arduino from USB. You can go to Tools and Ports and make note of whatever ports you have in there. You might have none. Then plug your board back in, go to Tools Port again, and you'll see a certain port populated, and that's the port for your Geek Arduino. If you don't see it, go back to the Getting Started guide and make sure that your FTDI drivers are set correctly. So now you can go ahead and click Upload. Down here you'll see all of our settings, 2009, 328, and the serial port we picked. First it has to compile the sketch, then it'll upload sketch. We'll see the red lights on the Geek Arduino and get this done, uploading message. So now our Geek Arduino shouldn't be doing anything. We should just have that power light on. Let's go to File, Sketchbook, RobotGeek Sketches, RG101, Digital Output, A Digital Output On. Now, if for whatever reason you don't have this RobotGeek Sketches, make sure to install the RobotGeek libraries in the Geek Arduino Getting Started guide. This first guide is just going to have us turn a single LED on. Here's our digital output on code. Actually, let's jump back to this bare minimum. As you see, there's a setup and a loop. Setup code runs once, so it's where you set up all of your pins and everything you want when you want to start your program. Loop will keep running over and over and over again until the Geek Arduino is powered down. In this digital output on, you can see that we're just using the setup. There's no code in the loop. So we've got two functions here. The first one is pin mode. Pin mode allows us to define what kind of pin the pin should be. So the options are output, input, and input pull-up. We'll talk about the other options later, but right now we're going to use output. So the first parameter is 13. This is the number of the pin we want to control. And if we look on our Geek Arduino, we see this row of digital pins. 13 is one of the pins. Now it happens to be that there's an LED tied to pin 13 on the Geek Arduino. This is an Arduino standard, and it's used for testing procedures and teaching Arduino just like we're doing right now. So this function is saying, set the pin mode of pin 13 to output, because we're going to be using it for an LED. The next important function is digital write. Just like pin mode, it has two parameters, the first one being 13, but the second one is how we want to set the pin. So right now we're just going to set this high. By default the pin is low or off, but we're going to tell it to go high or on. When it's on, it gives 5 volts to the circuitry, turning the LED on. So let's go ahead and upload this. I'm going to go ahead and bring down our lighting a little bit so you can see better. But now we see this LED that's on all the time. The next thing we're going to do is go to File, Sketchbook, RobotGeek Sketches, RG101, Digital Output, Blink Basic. This is going to turn the LED on and off at a constant rate. As you can see, our setup now just has pin mode. This is because we only need to set the pin mode once. As soon as it's an output, it'll stay an output until we call pin mode again. Now we're finally using our loop. You can see the familiar digital write, 13, high. Then we have a delay. The delay function is going to tell the Arduino to do nothing. It's just going to delay or wait. The parameter 1000 is in milliseconds. So this function tells the Arduino to wait for 1000 milliseconds or 1 second. The next digital write looks a little different because while we're still calling pin 13, we're now calling it low. That's setting it back to 0 volts and turning the LED off. Now we have another delay so that this low persists for 1 more second while the Arduino is waiting, and then it goes back to the beginning of the loop, going over and over and over again. We'll upload this. Now we should see our user LED turning on and off at a constant rate, blinking every 1 second. Now let's go to File, Sketchbook, RobotGeek Sketches, RG101, Digital Output, Blink with Variables. We're going to do a quick introduction to variables for you. Now in another video we're going to go over variables more in depth, but for now you can think of variables as boxes where you can put data. This data can change throughout the program or stay the same. In our case, our variables are going to stay the same. For the syntax of a variable, you have the kind of number you're using, the name, an equal sign, and the value that you're initializing the variable to. Int means integer. So this is a variable type that holds whole numbers from about -32,000 to positive 32,000. Digital output pin is the name that I'm going to use for the code. You usually want to make these self-documenting so that it's really obvious what is held in that data. You could name this whatever you want. You could name this DOP or Kyle, but those probably wouldn't be very good variable names. Equals just so that I can now assign this value into the variable digital output pin. So I'm going to use 13 since we'll be controlling digital out pin 13. I've also got another integer called delay time where I'm going to hold the amount of time that we wait, 1000 milliseconds. In my setup, just like before, I've got my pin mode, only now instead of calling pin mode 13 output, I'm calling pin mode digital output pin output. So then the code will go back to this variable, take this value of 13 and pass it to pin mode. So I'm still doing the same thing as when I did pin mode 13 output. Similarly with these two digital writes, instead of digital write 13, I have digital write digital output pin, digital write digital output pin. And in delay, instead of delay 1000, I have delay time. So let's go ahead and upload this to our Arduino. As you can see, we're getting the exact same behavior as before with the LED blinking. Now, one of the really nice things about variables is that I can make changes really quickly to my code. So let's say I want the LED to blink 4 times as fast. Instead of 1000, I'm going to put 250. That way it only waits 250 milliseconds or a quarter of a second before changing states. Let's upload it. As you can see, the LED is blinking 4 times as fast. If I wanted to do this in the old code, I would have had to change 250 here and 250 here. Now let's add a sensor shield to the mix. The RobotGeek sensor shield makes it really easy to plug different devices into your Geekduino or Arduino board. It has pins that match up with the Geekduino, so all you need to do is fit the pins in on both sides and gently push all the way until the sensor shield is completely seated. The Geekduino has 3 columns of 3-pin headers. The first column is for analog inputs. We'll go over it in another video. The other 2 are for digital inputs and outputs. We'll mainly use this middle column. The third column is used for digital outputs that can also use PWM, and we'll use those for some other features later. But for right now, we're going to focus on pin 13 all the way at the bottom of this middle column. Now you'll notice that each column is labeled S, V, G. Those stand for signal, voltage, and ground, and all the RobotGeek sensors need these 3 connections. Signal is the data coming in or out of the Geekduino. V, or voltage, is 5 volts. That's the power going to your device. And G is ground, and that's where the power returns back to the Geekduino. So the V and G create an electronic circuit where the electricity can flow. So it needs all 3 pins to work properly. We're going to take a RobotGeek 3-pin cable that has a white, red, and black connection. We're going to use white for S, signal, black for G, ground, and red V will stay right in the middle. So all we need to do is take our cable, fit it onto this 3-pin connector, make sure that we've got white to the left towards S and black to the right towards G. Now we'll take a look at our RobotGeek LED driver. The LED driver should come with several different colored LEDs, so you can pick whichever color you want to use. You'll notice a little graphic here of the LED. You'll see one leg is longer than the other, and you'll also see internally these sort of little shapes. And if you look at the LED, you'll actually see the same shapes. One is a little bit smaller, one's a little bit bigger. So match the LED up to that graphic and fit it into this port. Alternatively, you can also have the pin going straight up, like this. And that's what we're going to do to make it a little bit easier to see. Now the other end of the 3-pin cable that's plugged into the Geekduino is going to get plugged into our LED driver. And just like before, you'll see S, V, and G labeled on the silk screen on the board. We're going to go ahead and plug this in. And you should see the LED blinking just like the LED blinked on the board on the Geekduino. This is because pin 13 is tied to that same LED, and we didn't need to make any code changes to make this happen. Now what happens if we want to use a pin that's not pin 13? Let's take a look back at our code. We've got this variable, digital output pin 13. So let's set that to 2. What that's going to do is wherever this pin mode in digital write is calling the digital output pin, it's going to call 2 instead. Let's go ahead and upload it. You'll notice that your LED is going to stop blinking. You're going to get this done uploading and nothing's happening. That's because we're still plugged into pin 13. So let's go ahead and plug into pin 2. It's going to be the 3rd pin down in the middle of the column. There we go. We're blinking again. If we would have gone back into this blink basics and we wanted to do the same thing, we would have had to change all of these to 2. Now right here that's pretty easy, but when your code gets bigger it can be really helpful to be able to use these variables. At the digital output level, the Geekduino doesn't really know what kind of sensor is plugged into it. It's just turning a switch on or off, 5 volts or 0 volts. This can be really handy because let's say we have a buzzer instead. We'll unplug the LED, make sure that we've got our white, red, black matched up to SVG on the buzzer. And now the buzzer is beeping at the rate that the LED was beeping. We can even use a relay board. You'll see the LED on the board You'll hear the click of it coming on and off, and if you had something attached to the relay board, you would see that going on and off at the same rate. There are more advanced topics in digital output. If you want to take a look at RobotGeek Sketches, RG101 digital output, you'll see blink with constant variables. This is a way to save memory when you're working with your Arduino, especially with variables that you know aren't going to change throughout the program. We've also got blink without delay. This is a way to blink your LED without blocking the Arduino. So this can be really handy when you've got really busy programming code. It's doing a lot of things and you can't afford to wait a second just to have the LED blink. In the next video, we're going to be looking at our digital output, lesson 2. And that's going to teach you how to use different digital inputs to control the digital output.